Okay, so besides the bidirectional recurrent neural nets, we can also have some other variants of the RNN model actually. In this page, we want to discuss another variant which is called hierarchical RNN. This model instead. What is a hierarchical RNN? So before we introduce this architecture for the hierarchical RNN, we want to discuss the structure of the document first. So normally we know that inside a document we have several paragraphs, right? A document can contain several sequential order of paragraphs. At the same time, one paragraph can contain several sentences in a sequential order, right? And each sentence can contain multiple words in a sequential order as well. Then you can see the document can be represented as a hierarchical structure. The document has multiple paragraphs, paragraph has multiple sentences, sentence has multiple words, right? So in other words, the documents we have in the real world, they are not just one sequence, right? They can be represented as a hierarchical structures. Also, among some of the even though they are very far away in the document, however, actually they have some like correlation in the semantic meanings, right? So therefore, some people propose to consider this hierarchical structure of documents in learning, especially for the representation learning of the paragraphs for the sentences, for example. And you may also wonder why we need to consider this. Why just consider this one as one sequence data? The main reason is because like if you write some novels, if you have ever write some novels or some articles, you know, normally the paragraphs which are very close and nearby, they will have very strong correlation with each other, right? However, sometimes if we have a very decent organization of the article, right? So for some of the paragraphs which are far away, they have even closer correlation with each other. Now this one denoting some reasons for some of the events, and you illustrate the result of the event at the very end instead, right? Even though in the organization structure of this paragraph, they are very far away from each other. However, from a logical perspective, these two paragraphs probably will be much closer to each other than the others, right? Therefore, to capture such kind of structure among different paragraphs or among different sentences in the documents, we need to consider this hierarchical structure of documents in learning. Then you may wonder, how can we further extend the recurrent neural nets to capture these hierarchical structures in learning? So we can represent or we can extend this recurrent neural nets into the hierarchical way actually. We define this hierarchical recurrent neural nets for document classification. We need to trace the architecture in this page. So how to read out this architecture? We can read this architecture from the bottom up actually. So let's have a look at the bottom part. The bottom part is very similar to what we showed before, right? We have multiple words inputs, W21, W22, and until W2T, right? This is denoting the words in the sentence 2 actually. And we want to learn the embedding vectors for these words, right? And the way we learn the embedding from these words is by utilizing what? By utilizing a bidirectional recurrent neural nets, right? We have the bidirectional recurrent neural nets from both left to right and then from right to left, as shown here, right? So in this way, by utilizing this bidirectional recurrent neural nets, then we can learn the embedding for the words in the second sentence, right? In the second sentence. Then here we want to further define the embedding vector for the second sentence by integrating all the words we have here, right? So the way we do the integration is by summing all the vectors we have from both from the bidirectional recurrent neural nets together to define the embedding vector for the S2 for the sentence 2. Then in this part in the architecture, we have a very tricky part, which is one variable is the UW as shown here. What is this UW? This UW actually denoting a vector. It denotes one vector variable. It is a variable to be learned. So to understand this kind of part, we have to understand a very important concept. It's called attention. We will discuss the attention in the next part, in the next lecture, in more detail. So you can understand that attention is something like a weight, right? And by utilizing this UW, this vector, together with this learning embedding vector, like H vector that's shown here for the words, we can calculate the attention scores, which is similar like the weight scores for the embedding vectors. So this variable together with the learning embedding vector will define the weights, which is called attention score for different embedding vectors. So we mentioned here we need to sum all the embedding vectors together, right? However, different vectors will have different weights. The weights are defined by the attention score we calculated here. And you may wonder, how can we define the attention score like alpha to 1? We can just define alpha to 1 as the inner product between UW vector with this H vector, right? This inner product, we can define one score, right? And of course, we can also have some activation function here to define a score. So according to the attention score, which denotes the summation weights, we can integrate all the hidden representation of the words together to calculate the representation for the sentence true as shown here, right? In a similar way, we can also calculate the hidden representation of sentence 1 and the sentence L. So by utilizing the bottom part, which denotes the word bidirectional recurrent neural nets as encoder, we will be able to encode all the raw text inputs to learn the embedding vector for the sentence true, right? All the sentences are shown here. So based on the sentence, we can further integrate the sentence representation together to define the representation for the document or for the paragraph as well. So the way we learn the embedding for the sentences, we have S1 and the SL, which are aggregated from the lower part. We can treat them as raw inputs for the sentence encoder, right? So for the sentence encoder, we also define it as with these bidirectional recurrent neural nets. So given the S1 and the SL as inputs, we can also have this bidirectional RN as shown here from left to right and from right to left. This will be serving as encoder for the sentences. Right? These are the sentence encoder. So based on this S1, SL with the embedding vectors together with the bidirectional RN, then we'll be able to learn the embedding vector for the sentences according to the neuron that we show here. And next, we want to further integrate this representation learned by the sentences together to define the representation for the document, for example, right? And we want to further integrate them together. And in the integration process, we want to differentiate different sentences, assign them with different weights. Here, we also introduce another variable, which is for the sentence, right? This is US. This is S denoting the sentence. This is U is a vector. So we also introduce another variable US as shown here. This one will be serving as a variable for calculating the attention scores for different sentences. So by calculating this inner product between this US with this H vector, we can define its attention score, which will be serving as weights for the summation of all the sentence hidden representations. You can follow me, right? So by summing all the H1 and in both directions together according to the attention scores, we can define the representation for the paragraph. In this way, we can learn the representation for the documents, and then we can further classify this document into different classes and with this softmax function, right? Okay, so you can see in this architecture, compared with the vanilla recurrent neural nets, so in the chain structure, this one has a architecture, right? And we have a sentence, we have words to sentence, sentence to documents, these hierarchical structures there. And this kind of architecture can carry more rich information inside documents, and it can also learn much better representation for the documents as well. So, I mean, this kind of architecture will be much more complex, actually. I'm not sure if you can try to implement this one by yourself or not for your projects, because we have one of the tasks which is for classification of documents. And if you are interested, you can also try to play with this one, I mean, by utilizing this hierarchical recurrent neural nets for classifying documents as well for the projects. Okay, but but this one will be optional. If you are interested, you can try to play with them. If you don't have much time, then you just can leave this one as some other extra exercise probably after we finish all the courses in your future projects instead. Okay, so that's it for this section, and here is a summary for the section. In this section, we discuss how to do the natural language processing as well as word embedding problems, right? In the very beginning, we provide you with an introduction about history of natural language processing. Then we discuss a problem which is called word embedding with word to vector, this kind of methods, right? In this method, we introduce two different variety methods. The first one is called CBAL, and you can also remind yourself what is the architecture of CBAL. I mean, we try to infer the surrounding context, I mean, given the current words, right? And you can also remind yourself how can we learn the CBAL model. I mean, we try to compare the prediction versus ground truth to learn the model, and then we can further learn the embedding vectors for the words, right? And besides CBAL, another variety model we have introduced before is called a skipgram, right? In other words, we try to infer the surrounding context based on current words instead. It works in a very different way, and you can also remind yourself how can we learn this model. And we also provide you with a summary about similarity between both the similarity as well as difference between CBAL and skipgram, right? These two methods and their potential difference in the performance as well. And after that, we discuss how to use the recurrent neural nets for the text generation with RN, right? We discuss how to design RN architecture for generating the text. So we will provide you with different choice for the recurrent neural nets, for text generation, right? Besides, we can generate one single output, we can also generate multiple outputs simultaneously by changing this architecture, right? And after that, we talk about the bidirectional RNN as well as the hierarchical RNN. The bidirectional RNN can capture the patterns from both the words ahead as well as after the current words. As to the hierarchical RNN, it can capture the hierarchical structure of the documents in learning the embedding vectors for the documents, right? And inside the hierarchical RNN, we also mention a concept, it's called attention. And this attention is a very important concept in deep learning nowadays, and we can discuss more information about attention in the next lecture instead. Okay, so we also have some after-class tasks for you to try to do. So first of all, please read the textbook on RNN section as well as some extra reading materials we'll provide with you. Also, it's time for you to start to do the project stage 4 now. I think you should have enough knowledge already to try to play with the recurrent neural nets to do both the document classification as well as generation. And we also provide you with some links for some source code, for word embedding with PyTorch as well as bidirectional recurrent neural nets. And you can play with them if you have time. Okay, so generally that's it for this section, and thank you for your time and attention to this section.